Okay, let's take a look at example 4. This problem may be one of the few problems that some of you struggle with, but you can always adopt a very simple strategy to solve this problem. So let's take a look at the problem itself. A rectangle was altered by increasing its length by 10% and decreasing its width by p%. If this alteration decreases the area of the rectangle by 12%, what is the value of p? So the best way to do this, and I'm going to solve this in two ways, but the best way to do this is to actually to create your own rectangle. So let's have our own rectangle here. This is our own rectangle. We're going to create our own little rectangle, and we're going to call this rectangle of length 10 on width, of length 20 and width 10. So if you follow the logic here, they say we're going to increase. If we increase the length by 10%, that means 10% of this becomes 22. So the new rectangle will be this, and we are decreasing the width by p. So this one will be shorter too. So we're going to have something like this. So this will now be 22, and this will be 10 minus p over 100 times 10, right? That will be the new right. So, and it interestingly, the area here is 200, that the original area, and they are saying that this new area here is actually 12% of this. So this here, the area of this new will be equal to 12%. So that's, in essence, is going to be 0.88 of the 200, and that becomes 176. That is a new area. So how do you find the value of p? So I'm going to set it up this way. I know that the new area here, this new rectangle here, is going to be equal to, say, 176 should be equal to 22, which is my new, times, and I need to subtract this. That would be 10 minus p over 100 times the old 10. So technically it's pretty much like p over 10, like that. So this is my new area. How do you find the value of p? Now you can, once you have this equation, this becomes a simple algebra. You can, distribute it and find the value. This is 10, and find the value of p. But the quickest way to do this is to actually plug in the values of, because these are supposed to be p, plug in the value. So I'm going to plug in. So when I plug in the value of p here, this becomes 22, 10 minus p over 100 is 0. So that 0.12 times 10. And when you do that, you get 193. So obviously that is not correct. Let's plug in 15. When I say 15, that will be 22 times 10 minus 0.15 times 10. When I do that calculation, it gives me 187, something like that. That is wrong. Let's go to 20. So when I plug in 20, it gives me 22 times 10 minus 0.2 times 10 will be equal to, it gives me 176. Now notice that I'm looking for 176. So obviously the p that I'm looking for will be this one. Will be p is equal to 20%. And that is how you solve this. Now, algebraically, what you can also do is you can actually start like this. You can say that my original rectangle is xy, and the new rectangle will be this. This will be 1.1x, and this will be y minus p over 100 times y. So if I set the two equations together, that means I can say that the new this here, the new area, this will be 1.1x, which is my length, times y minus p over 100 y will be equal to 0.88 xy. If you want to solve this algebraic, this is what you do. And once you go through this process, you should be able to, the x, y will cancel out and you find p, and you still get p, it will be equal to 20%. Right? So if you want to go through that process, that is how you solve this problem and get your answer. But this is going to take you more time, and it's pretty much designed for students who have a very strong algebra background to do that. Otherwise, set this up like this and plug in the values, and you should be able to. Now, even at this point here, you can, this has become a simple linear algebra that you can solve for the value of p. Otherwise, you can plug in the value of p. The one that gives you 176 will be the answer that you'll be looking for.